Okay, let us now move to the experiment. So we have to do the second experiment, which is on TRIAC and AC phase control. I had already discussed the theoretical aspect of this experiment. We basically have to study a dioc based trigger circuit, and then we have to use that trigger circuit to fire our TRIAC. Okay, so let us start with the circuit. So this is the circuit that we would be using. This part of the circuit is the triggering circuit. Okay, so this is the supply, this is the load, and this is the dioc, and this is the TRIAC. TRIAC is a 3-terminal device, and I had told you that in a TRIAC you could fire a TRIAC in the positive half as well as negative half cycle, negative half AC cycle. Okay, that means it can be used to control an AC voltage. Okay, so let us see the arrangement of the circuit here. So this is a board on which various components of the circuit have been used. So starting from these two terminals, which are coming from a auto transformer, the supply is given here. Then after that we have got this the TRIAC is here. This is the TRIAC. Okay, and along with it we have this dioc. So TRIAC and the part of the triggering circuit is here. Fine. The two terminals MT1 and MT2 have been shown here, while the third terminal gate of the TRIAC is here. Is it fine? So we are basically connecting this to this by arrangements of wire. Okay, this is the knob. This is the potentiometer, also in short we call it pot, and by changing the resistance we are controlling the firing angle, and thereby we are controlling the output voltage. So you see, we will start by giving a supply to the circuit. So we are keeping the input supply at around 265. So let us measure it. It is not exactly 265 as shown here. So I am actually measuring this supply with the help of a multimeter. It is 234 volts RMS value. Okay, so after giving the supply, I would now be increasing I will be rotating this knob, increasing the resistance, and thereby controlling the output voltage. Okay, so you see, this green line is the input voltage, and this is the output voltage. It will actually be overlapping it, but to show it clearly, I have reduced the magnitude, the appearance of the waveform here on the DSO. Okay, actually they are having the same magnitude, but to make a distinction so that they do not overlap, I have just shown it like this. Okay, so I now the triggering angle would be controlled with the help of this knob. So this triggering angle is being increased, and you see in the positive as well as the negative half cycle, you could see the firing is taking place. Okay, and just see, and the output voltage, it is varying, starting from say 202. The supply voltage we gave was 234, no, 231. Now it is 202. Again we can reduce it further, 198, 180, 178. So there is a smooth control of the output voltage. We can actually go up to 180 degrees. Okay, so this is the AC phase control of the supply voltage, and this controlled output voltage can be given to any motor, single phase induction motor or anything which operates on AC supply, and by controlling the voltage we can control the speed of the induction motor. Okay, is it fine? So this is the load which is connected across this circuit. This load is there, you could see here this load. Now coming to the sheet, so basically you have to note down the readings, serial 1, 2, 3, 4. What is the input voltage, which was actually 234 volts, and the output voltage, and the firing angle you have to calculate from the DSO. You can observe the firing angle, you can calculate it from the DSO. So I would actually be clicking the waveform and I will be sharing it with you, so you can calculate the firing angle from there. Okay, these are some of the questions that you have to do, and it is expected that you would be doing these experiments, these questions. Now in order to calculate firing angle, just you see how we can calculate. You see from this point to this point, this is 90 degree. This one cycle is 90 degree. So it is taking two divisions in the x-axis. So these two divisions correspond to 90 degrees. So this firing angle can be calculated easily. Okay, so you just note on, I think that it is around 2.5 or 3 divisions is there, and so if these two complete two divisions correspond to 180 degree, then this is around 0.5 division is there, and you can find out the angle corresponding to it. Okay, so I would be taking some snapshot of the angles at various instances, and you have to calculate the firing angle and note it down on the sheet. Okay, so thank you.